question reads the masses in kilograms of 20 bags of maize were 90, 94, 96, 98, 99, 102, 105, 91, 102, 99, 105, 94, 99, 90, 94, 99, 98, 96, 102, and 105. We are told using an assumed mean of 96 kilograms, calculate the mean mass per kilogram per bag of the maize. So we've been told to get the exact mean. We've been told to get the actual mean. We are told to get the mean mark of the 20 bags of maize in kilograms if the assumed mean given is 96 kilograms. So the data I've just read to you is ungrouped data. Random values given in terms of the masses in kilograms of 20 bags of maize. So you're supposed to prepare what you call a frequency distribution table that can capture all that information, and you can be able now to get the exact mean or the mean mass per kilogram per bag of the maize. So you're going to actually have this. You're going to have the first column reading mass in kilograms, and the second column can have what you call a frequency. So this is called a frequency distribution table that can actually translate the ungrouped data into grouped data. So the data can actually capture the following information. One, we have to look at that data and give the lowest mass in kilograms of the bag of maize. And the lowest mass in kilograms is 90. How many times does 90 appear in the data given? Once, right?
Twice.
So we are going to put here 2. Then how many times does the second value, which is 91, appear?
Once.
Once. And do you have 92?
No.
93?
No.
94?
Yes.
So how many times does 94 appear? So we have 1, 2, 3.
Yeah, 2 times.
Do we have 95 in our data?
No.
96? Yes. So how many times does 96 appear? So we have 1,
2.
then 2.
Yeah.
So 2 times. Do we have 97?
No.
Then we shall go to 98. How many times does 98 appear?
2.
So we have 1, then 2. So 2 times. 99?
No.
We have 99,
Yeah,
right?
we have 99.
1,
1, 2,
2, 3, 4.
Yeah.
4 times. Then we shall go to, do we have 100? No. 101? No. 102?
Yes.
So can we get the frequency for 102 in the data? 1, 2, 3, yeah, 3 times, right?
Yeah.
Then we shall go to 103. Is there 103 in our data? No. 104?
No.
104, no. 105?
Yes.
How many times?
1, 2.
1, then 2, 3. We have 3.
1, 2, 3.
Okay. So we have prepared a frequency distribution table. And sometimes preparing a frequency distribution table demands that you also come up with what we call the tally. The tally can be able to get captured in this manner. For example, I can actually say this is 2. So if my frequency is 2, then I'm going to have 2 sticks getting drawn. If it is 1, I'll just draw 1 stick. Then 3 of them are going to be captured here. Then you have 2. We have as well 2. We have 4. 1, 2, 3, 4. 3, 1, 2, 3. Then 3, 1, 2, 3. So you can get the tally from what you've been given as a frequency. If the number is 2 as a frequency, you're going to actually have 2 sticks getting drawn. If it is 1, you only capture 1 stick. If it is 3, you have to capture 3 of them. If it is 2, you capture 2. If it is 2, you capture 2. If there are 4, you capture 4 of them. If it is actually 3, you capture 3. If it is 3, you capture 3. So this is what you call the tally. It can correspond to the frequency given in the second column of the data given. Now, we are told to use the assumed mean of 96 for us to get actual mean or the mean mark or the exact mean of this data. Okay, what do? The formula is going to be, so mean mark. Mean mark is equal to assumed mean plus the summation of frequency times deviation divided by the summation of frequencies. Now, you're supposed to get the mean mark, the exact mean, the actual mean, the real mean of this data. You see, of the masses in kilograms of 20 bags of maize. And you're going to use this formula. You're going to say the assumed mean given in the question plus the summation of frequency times deviation, then divided by the summation of frequency. I have no problem in terms of getting the frequency. The frequencies can get captured. But the problem is the deviation. So D stands for, so the D we have in the formula stands for deviation. What is deviation? The difference between the values given or the data from the assumed mean. What is deviation? The difference between the data given in terms of the masses of the 20 bags of maize in kilograms from the assumed mean. So I'm going to create a column that is going to give us the deviation. So I'm going to have this as my column to get the deviation. So how do I get the deviation? So I'll be able to capture this. I'll say deviation D is equal to the data given, the values given in the first column, less the assumed mean. That gives us what we call the deviation. So I'll pick the data given, those values in the first column from 90 to 105. Then I have to subtract the assumed mean from these values. You get the point? So we're going to have here X. Obviously, if the data is ungrouped, the random values given in that data can represent our X. But for the grouped data, getting X means you're getting the midpoint. You add the two limits of that class, divide by 2. So here, let's get the deviation. So for example, in the first part, I know my X is 90. So I'll pick 90, then I say 90 less the assumed. And our assumed is what? 96. So the answer becomes negative 6. That becomes my first deviation. My second deviation, I'm going to pick X, which is 91. Then I say less the assumed mean, 96. The answer becomes negative 5. The third, I'm going to say 94 less 96. The answer becomes negative 2. The next becomes 96 less 96. The answer is 0. The next is 98 less 96, and the difference gives us 2. Then we have 99 less 96, the answer is 3. Then we shall take 1 or 2 our X, because it's X less assumed. So X is 1 or 2. The value of X, 1 or 2, less the assumed 96 from this end, it gives us a difference of 6. We shall come and take 105 less 96. What are we going to get as our answer? 105 less 96, we shall get 9. Right? So we are going to create another column of FD, because our aim was to get D. We've gotten the deviations of those values or the data given or those numerals from the assumed mean, then this has given us the deviations. The next thing is to get, so we are going to have a column of FD, frequency times deviations. Correct? So I'll be picking my frequency, I multiply by the deviation obtained in this column. So I'll have, for example, 2 as my frequency multiplied by my deviation, negative 6. And the answer becomes negative 12. In the second part, I have a frequency of 1. Then I'll say 1 times the deviation is negative 5. The answer becomes negative 5. So I'll do that for the rest of those values. So I'll take 3 times the deviation, negative 2. I'll get negative 6. I'll come and say 2 times times 0, I'll get 0. I'll come and take 2 times 2, and I'll get 4. I'll come and take 4 times 3, and I'll get 12. I'll come and say 3 times 6, I'll get 18. Then I'll take 3 times 9, then I'll get 27. So at the end of the day, I'm going to actually make a line that is very horizontal to this table. And at the end of the day, I'll have to capture 1, the summation of the frequencies. Why? At the bottom here, we have the summation of the frequencies. Does that mean? So we need to get the summation of the frequencies. To mean, our answer must be 20. Why? We were told that there were 20 bags of what? Of maize. So 2 plus 1, that is 3. 3 plus 3, that is 6. 6 plus 2, that is 8. 8 plus 2, that is 10. 14, 17, then 20. So the summation of the frequencies is 20. So you're supposed to get the summation of all these values of FD. So we had in our first case here, negative 12. In this second row, we have negative 5. How do you get these values? I actually told you, you take 2 times negative 6, you get negative 10. Then I say 1 times negative 5, you get negative 5. So you're going to add those values to get the summation of FD. So what's the answer when you add all those values? Can someone give us the answer for the values in the column of FD? So we have get from the calculator the sum of.
So this is what I.
We're going to say negative 12 plus negative 5 plus negative 6 plus 0 plus negative 12. So plus 18 plus 27. So we have negative 12 plus negative 5 plus negative 6 plus 0 plus 4 plus 12 plus 18 plus 27. It has given us 38. So we have 38 as our answer. So we shall come here and get now the mean mark. So how to get the mean mark? Mean mark is equal to, the assumed mean given is 96. So we shall write 96, that should be mean, plus the summation of frequencies times deviations. It has given us 38. The summation of FD. The summation of FD is 38 divided by the summation of F. The summation of F is 20. So I'll just take 38 divided by 20. So 38 divided by 20 gives us 1.9. So we shall say 96 plus 1.9. We shall now be able to get the actual mean, X bar, the actual mean. So 96 plus 1.9, that gives us 97.9 kilograms. Because they told us to get the mean in kilograms of 1 bag of maize. That's the end of that question. We got the answer as 97.